let's pick up where we left off with inverse trig derivatives examples, class examples. Example 5, find y prime for y is equal to arc tangent of 4x. So I'm going to go through the implicit method first. So we're going to identify the inverse function of arc tangent, which is tangent. So we take tangent of both sides to allow the right side to cancel out. So tangent of y is equal to tangent of arc tangent of 4x. This will cancel each other out to be just 4x on the right side. Now we're going to find the derivative of both sides, and implicitly, because y is mixed in with was inside the tangent function, so tangent of y becomes secant squared of y times dy dx. 4x becomes 4. Okay. Solve for dy dx by moving the secant squared y to the other side, so 4 over secant squared y. I'm going to move the secant squared y up to the top and just have it in terms of cosine squared y. It's a little bit easier to think in terms of cosine. So now we have 4 cosine squared, and then we want to work towards getting the right side to be in terms of x, and then in terms of values for given our trig ratio. So y can be replaced with our original equation, arc tangent of 4x. So now we have 4 cosine squared of arc tangent of 4x. Okay, so now we got to figure out the triangle that's produced from arc tangent of 4x, and then we can find the cosine squared of that angle. So tangent, arc tangent of 4x can be thought of as tangent of theta is equal to 4x, 4x over 1, opposite over adjacent, so 4x over 1. Use Pythagorean theorem to find out the hypotenuse in terms of x, so square root of 1 plus 16x to the x squared. So now we want to find cosine of theta. So cosine of theta is simply 1 over adjacent over hypotenuse, so 1 over square root of 1 plus 16x squared. But we don't want to forget we have to square that, right? So 4 times the ratio squared. The 1 will remain 1, but the denominator, the square root, will cancel out, so we're left with 4 times 1 over 1 plus 16x squared, or just 4 over 1 plus 16x squared. Okay. Or we could find the derivative using the derivative rule from above. So the rule for arc tangent of u, the derivative is simply going to be u prime over 1 plus u squared. So if we identify the u value as what's inside the arc tangent, which is 4x, so then u prime will simply be the derivative of 4x, which is 4. Okay. All over 1 plus u squared. So 1 plus our u value is 4x, so 4x squared will turn into 16x squared. So 4 over 1 plus 16x squared. So it's a lot faster to go through your derivative rule. However, that also means you have to memorize through formulas, and these are more easily to forget than the implicit rule. So again, I would suggest knowing both rules, and you can apply whichever one is best for whichever problem you're working on. Okay, number 6, find y prime for 2 arc secant of 3x squared. Okay, in order to take the secant of both sides, I need to move this 2 out of the way, so we can just so we can have secant of arc secant of 3x squared. So this 2 needs to move to the left side first. So I'm going to go through this implicitly first. Take the secant of both sides in order to cancel out the right side. So secant of arc secant of 3x squared, and also secant of y over 2. Okay. The right side will simply become 3x squared, and then now we're ready to find the derivative. So remember, the derivative for secant of u, right, is secant of u tangent of u times u prime. So the derivative of y over 2 is simply 1/2 times dy dx. And then 3x squared, derivative is just 6x. Okay. One step at a time, we're trying to solve for dy dx. So divide both sides by 1/2, which is simply as multiplying by 2. So that'll give us 12x. Divide both sides by secant tangent. So if I divide both sides by secant tangent, I can move the secant and tangent up to the numerator as cosine of y over 2 and cotangent of y over 2. Okay. And then y over 2 can be replaced with arc secant of 3x squared, because after we move the 2 initially over, this y over 2 can now replace the can be replaced with arcsecant of 3x squared. Okay. So now we have 12x cosine of arcsecant of 3x squared, cotangent of arcsecant of 3x squared. So we're trying to find the cosine of the angle when the secant is 3x squared, and also cosine and cotangent. So based off of arcsecant of 3x squared, we can create our triangle. Secant of theta is equal to 3x squared. Secant is simply hypotenuse over adjacent. So 3x squared over 1. Use Pythagorean theorem to find the third side. Hypotenuse squared minus adjacent squared is equal to opposite squared. Take the square root of both sides, so 9x to the fourth minus 1. So now we go back here. Cosine of the angle is simply going to be adjacent over hypotenuse. So adjacent is 1, hypotenuse is 3x squared. So 1 over 3x squared. And then cotangent of my angle is simply going to be adjacent over hypotenuse. So adjacent is 1, adjacent over opposite. Adjacent is 1, opposite is square root of 9x to the fourth minus 1. So 1 over square root of 9x to the fourth minus 1. And we plug all that into our equation here. So 12x times this is 1 over 3x squared. Cotangent becomes 1 over square root of 1, square root of 9x to the fourth minus 1. Okay. We can put all this into one fraction. The 12 and 3 cancel out to be 4. X and x squared cancel out to be x. And then square root of 9x to the fourth minus 1. Okay. We need absolute value of x because the hypotenuse can never be negative. So this x has to have an absolute value bar around it. Okay. The other method, we can use derivative rules. And the derivative rule for secant, okay, is simply going to be, okay, I have it here as well. Okay, simply going to be u prime over absolute value of u times square root of u squared minus 1. Okay, so now my u value is simply going to be whatever is inside the arcsecant angle, arcsecant function, which is 3x squared. So u prime is simply going to be 6x. So 2 times u prime, 6x, all over absolute value of u. Absolute value of u is just going to be 3x squared times the square root of u squared minus 1. So u is 3x squared, so if we square that, that would be 9x to the fourth minus 1. The 12 and 3 cancels out, the x and x cancels out, so we're left with 4 over absolute value of x times square root of 9x to the fourth minus 1. Okay. We get the same answer regardless of whether we use implicit or use our derivative rule. Okay, example 7. Okay, find y prime for y is equal to x times arc cosine of 2x. If we look at this closely, we see that there's actually two functions here. Okay, we have an x, that's one function, and then we also have arc cosine of 2x, and that's a second function. So if we want to find the derivative of two functions that are being multiplied together, we got to go through product rule. F prime g plus f g prime. So this is where, if we know the derivative rule for arc cosine of 2x, we can go through it a lot faster rather than having to go through going through implicit differentiation. But I'll go through that step anyways. So product rule says f prime g plus f g prime. So f prime, derivative of x, is simply going to be 1 times the original g function, so arc cosine of 2x, unchanged, plus f, that's x. And then the next step is the derivative of arc cosine of 2x. Okay, so I just wrote this here to indicate that this does take some time to figure out if we want to go through implicit differentiation. So separately, I'm going to go through and go through the steps implicitly to find the derivative of arc cosine of 2x, so I can get to this part here. So y is equal to arc cosine of 2x, take the cosine of both sides, find the derivative, cosine of y becomes negative sine of y dy dx, 2x becomes 2, solve for dy dx, divide both sides by sine of y, and then y has to get replaced with terms of x, so y gets replaced with arc cosine of 2x. So we're trying to find out what is sine of theta when theta is arc cosine of 2x. So arc cosine of 2x is same thing as cosine of theta is equal to 2x. 2x over 1, adjacent over hypotenuse. Pythagorean theorem to get to the other side. Square root of 1 minus 4x squared. So sine of theta is simply going to be opposite over hypotenuse, square root of 1 minus 4x squared over 1. So that gets put in place of the denominator here, so negative 2 over square root of 1 minus 4x squared. Okay, so this gets replaced, this gets put in the place of when we find the derivative of arc cosine of 2x. Okay. Or if we want to go through the derivative rule, that could be a little faster, because we know the derivative cosine of arc cosine of u is simply negative u prime over square root of u minus squared, square root of 1 minus u squared. So our u value is going to be 2x, so derivative of 2x is going to be 2, and u squared 2x will simply become 4x squared. So it's a little faster to go through a derivative rule here, especially if we're in the middle of a product rule problem. So this is our derivative. We plug back into our problem halfway through. Okay. And then we found the derivative. Now the rest is just trying to clean up. Okay. Arc cosine of 2x minus, put this in the same fraction, 2x over square root of 1 minus 4x squared.